All right, so again, thanks for coming. Really appreciate it. Like I said, we're going to have some fun this afternoon. My name is Dave Boucher. I'm a senior engineer at SaltStack, and just live about 40 minutes south of here, Utah, so I hope you're enjoying our snow. This is the first snow we've had since like almost Christmas or something, so we were wearing shorts and riding our motorcycles to work the last few weeks, so anyway, lots of snow. So today we're going to talk about some advanced reactor use cases. So I'm going to assume for this class that you already have, at least a basic understanding of Salt. That's your Salt master. The general case, you have a Salt master connecting to your Salt minions on your servers. There's communication. You can run commands on those servers and everything. So we're going to kind of go from that base level there. If you have any other questions, on some more of the details about that, we can talk later after the class if you like. So, advanced reactor use cases. So I have a couple of examples here that we're going to talk about and a couple of demos that we're going to do. And the demos are kind of a little outlandish, but the idea is I kind of wanted to give you some view of potential of things you could do with Salt's Eventbus, Salt's Reactors, and the new beacons that you've probably heard of several times during SaltConf here. So, so the base of all this is Salt's really fast remote execution framework, right? Right now it's based off ZeroMQ. We're also working on another protocol called Rate. This allows a really rich sharing of information, passing information back from the masters to the minions and vice versa. Salt's Eventbus is where all this happens. The Eventbus, if you listen to the Eventbus, you can see events that are happening on your infrastructure. So simple things like when a new minion starts up, it'll send an event up to the master that'll say Salt, I think the minion's ID, and start. There might be something else in there, in a tag. And you'll see that come by. When you run a high state, and you run certain commands, a lot of those events will come back up to the master, and you can see those flowing through the event bus. And I'll show that in just a moment. We'll see what that looks like. Now you can actually do your own custom events as well. So on a minion, you can run salt call event.send or event.firemaster, and you can specify a tag, which you should namespace with your own custom namespace, so maybe your company name or your project name, and then // for whatever arbitrary length of a tag that you want. And again, we'll look at those in a moment. And then a data structure. A data can be any message pack serializable or JSON serializable data. So text, strings, ints, dictionaries, lists, things like that. Objects like Python objects, datetime objects, things like that will not work. They'll be stripped out. But again, anything that is JSON serializable, you can pass through there as data. So we can use that for our benefit. So I do have some slides that were put together for me, and I didn't find them very useful when I gave this talk yesterday, so we'll kind of go through them a little bit. This one was empty, so I just put "is awesome." Okay, let's start doing some live coding stuff. Oh, first of all, I just want to say I really like lots of questions and feedback and things. So at any time, if you have a question, please feel free to raise your hand, interrupt me in the middle of a sentence. Love to answer questions and things, so please feel free to do so. Let me switch my my profile. All right, so let's look at what the event bus looks like here. So let me open up another terminal. Actually, So in the Salt Git repo, in the test directory, we have a convenience Python module called eventlisten.py, and you can just run that, and that will just start dumping out all the events that come through on your event system. So if I come up here and I do salt, Boucher is a minion that I'm running. It's on my own server, so that's my last name. So when I run commands up here, you can see here's the event system telling me what happened here. So we had a command that was sent down to the minions, and then we had the results come back. So you can see here there's a tag associated with each event. Here's salt job. Here's the job ID and new. That means a new job that was created, was pushed out to the event or to the pub sub interface, or I'm sorry, to the pub interface. And then the this Boucher minions, we have salt job. Again, here's the same ID number for that job. Ret stands for return. And then this is the return from the minion named Boucher. So tags are what we match on in the reactor. I'll show you that in a minute, but I just want to kind of give you an idea of what these tags look like. And then here's the data structure that comes along. So we have the ret code. This is the return that came from here, the status of the call. It returned, it successfully ran. The job ID, the minion's ID, various things here that they're available in this data structure. The data in this return, we can send whatever you want. So for example, I can do salt call event.send. I can just send some data. Thank you. So we can see here, this is a return. So here's the actual tag that we sent. Some data was my tag. And we didn't have any data in it. You can also do and then we can do like a list of items. So these are engineers in our class today, for example. So, oh, I did it backwards. So, sorry, the tag goes first in an event, the FireMaster. So the tag was, I set to that. So the data goes first. So I always get that backwards. But anyway, so you can see there's tags and data and stuff that's flowing through the event bus. Well, yeah, the question was, what's the difference between FireMaster and Send? FireMaster was the original one that Tom wrote. The interfaces, kind of wonky. Seth, who spoke just before me, he just wrote event.send, I think the previous version of Salt. It's a little cleaner. Like you can just, yeah, they do the same thing basically. So probably event.send is probably what you want to use.
And you could send a data structure just like that from.
Yes, yeah. Event.send, for example, will, you don't have, it has optional arguments, so it'll automatically fill out some things for you and stuff like that. So. Either. So the question was, can you send them from the master or the minion? And yes, you can do either one. The master can send events, the minion can send events as well. So those are what the events look like. So let's look at reactors. So on the master, and actually I think it's been implemented already. We're actually going to have reactors on the minion as well. But a reactor is a process that sits on the master and listens on the event bus, and you can specify certain tags that you want to watch for. And when it sees those tags, it'll execute a reactor file, an SLS file, to do whatever you want. And within those reactor files, you have the full power of Salt. You can call out to other minions and run execution modules. You can execute runners. You can, call out Salt Cloud. Just anything you can conceivably do within Salt, you can do within a reactor. So let's look at what that looks like. Yeah. Yeah, so the question was, reactors can exist on the minions. Yeah, I think it has been implemented. So you can do the reactor on the minions at this point as well. So you can do things locally without having to wait for the master to decide what to do.
Well, can you set like any event across the bus from minion A and have minion B pick it up?
The question is, can you have a minion A send an event and have minion B pick it up? No. A minion can only send events on its local event bus or up to the master on the master event bus. The master reactor could do something then on minion B for sure, but for security reasons, everything goes to the master. Correct. That's exactly correct. So your question is can you have minion A send something to the master, have the master react, and then have the master then do something on minion B based on what minion A said? And yes, you definitely can do that. And we'll have some examples of that. So the first step to use a reactor is modify your master config. So Salt master. Oh. Okay. And there's a reactor section here. And here, then you can match on those tags. So here, I have a Jenkins tag I'm looking for. Here's a Technicolor tag here. And then here's a tag we're looking for a beacon that's happening. Now, if you noticed, here on this, here we have asterisks. So you can glob on certain sections. So if you remember down here on this tag, for example, we have salt job, job ID, ret, Boucher. So if I wanted to listen for any job that's returned by this Boucher minion, then I could match on salt job and then replace this with asterisk and then ret Boucher, and then I would only react on, I would actually react on any job that's finished or completed by the Boucher minion. And then, so you see here we have an item, and then we have a list. And each of these only has one item in here, but then we have just an SLS file that I tend to just stick them in /serve/reactor tests, or reactor directory, and then name the file. And again, this can be a whole list of VMs. I'm sorry, a whole list of SLS files that the reactor will hit when you will execute when you see that tag. Now, the matching that happens here is very, very fast. So when it's matching on the tag, it's got this process, and it can handle thousands and thousands of these at a time. And then when it matches a tag, the master will then split out to a worker process and have it execute the SLS files in order there. So anything that's a little more task intensive goes inside the actual SLS file. So you don't put commands right here. Sometimes a lot of people try to put in like CLI commands right there. That doesn't work. It all has to be inside your SLS files. So let's go look at those SLS files for the reactor. So I was using this example here to, so when I send a tag in, when I send an event on the bus, I would shell out I would call the Boucher minion and shell out the number of lines in that temp Dave file and stick it into temp Dave text file. So I can kind of see, then I would tell that file, and as I was matching things, you can see that file increase in the number of lines as it dumps that out. A couple things to remember. This is actually slightly old. The newer version of Salt, this should be local. So when you're on the command line, you're executing things from the execution module subsystem. And so you do things like salt star command.run. This example, this is analogous to salt Boucher, which is the target, command.shell. Local there refers to what we call the local client, which is an internal subsystem that deals with calling out to Salt like you would on the command line. If you wanted to execute a runner from in here in the reactor, you'd use the runner subsystem. So you'd do like runner.manage.down or runner dot whatever your runner you want to execute. If you're going to do use the wheel subsystem to like accept or reject minion keys, you do wheel dot key dot accept, I believe it is, and to manage all those things. So you have the full power of Salt, and you can use those different subsystems, but you're kind of like a step, you're like one level above, so you do have to specify which subsystem you want to use. So in this example here, this would be analogous to, on the command line, to Salt, Boucher, command.shell, and then in single quotes, wc-l, and the rest of that line, and that would get executed that way. So that's what we're going to be executing in this reactor. Okay, so that's on the master side. Now, let's go back to the minion side, and we're going to talk about beacons for a moment. So beacons are very new. The question is, if you're making changes to these SLS files, do we have to restart the master? No, you don't. If you modify the master config, like where those matching statements are, then you do have to restart the master for those. For these configs, you don't. Okay, so on the minion side, we have a new thing called a beacon. So when you're running a state or high state, and say you have a service that's watching a config file, and you probably should be familiar with the watch statement. So you can have watch. You can have a service watch, an Apache config file. If that file changes, then have it restart the Apache service, for example. One thing people kind of get confused about that, though, is that in that instance, that watch statement is not actually watching the file on the file system itself. It's actually watching the state that's managing the file on the file system. And if that state that's managing the file returns changes in its changes dictionary, then the minion service will be restarted. Beacons allow us to actually do things based on what's actually happening on the file system or other things that are happening live in real time on your minion. So we have several beacons that we've added. Beacons are available in 2015.2, which should be released very soon. We're trying to get it cut before SaltConf, but we weren't able to get it through QA quite yet, so it should be pretty soon. And some examples of beacons that we have are like an iNotify beacon, so you can watch directories or specific files, and when it sees a change, then it will send a message up to the Eventbus up to the master. We have a WTMP beacon that watches all the logins and logouts, and we'll do an example of that here. So every time someone logs in or logs out, it sends a message on the Eventbus up to the master. We have a Journal D beacon, a service beacon. I have a Twilio account beacon that I wrote, which we're going to demo here as well. So that's an example of something that's not even necessarily happening on the minion, but it's on a web service that we're going to be monitoring. And these beacons are really very simple to write. The service beacon is like 6 lines of code. The Twilio beacon has quite a bit of some timing information in there, but there's like 15 lines of code of actual meat of stuff that it does. They're very simple to do.
Are they part of the minion then? Not a separate process?
So right now, they are part of the main minion process. Tom and Mike, who work on some of the internals, They're planning on making its own separate process that's managed by the minion. But right now they are part of the minion process. And again, so the beacons actually don't do anything by themselves. All they do is check for some condition and then send an event up to the master with bits of information, that type of thing. So we're going to do a couple of demos today with that. So let's go ahead and do one. We're going to do our Twilio beacon. So you enable the beacons in the minion config. You can also put these in the minion's pillar data as well. So here in the, so this is my live Twilio account information, so please don't steal it. I'll be changing this after SaltConf. So we have a few bits of information that we need. This poll interval, I wrote this module before beacons had their own poll interval control interface. So by default, beacons execute once every second. They're tested every second. And there wasn't a way to modify that when it was first written. So inside of the Twilio module itself, I had a poll interval, so I could say I only want to hit them every 4 seconds. Probably in production, I would only do it every 10 seconds or something like that, just to be polite to them. But we're doing 4 here. There is an actual, I think it's just interval, where you can configure that for beacons in general. So you don't have to, you won't be hammering whatever system you're checking. So like I said, poll interval will be different in the correct way of doing this. So anyway, that's all we have to do. Okay. Now on the Eventbus, so this is the stream of data that's happening. Now, we have a subsystem called Salt API that allows you to enable, it's disabled by default, but you can enable a REST API that you can access from outside. So if you authorize against it, you can do, based on the permissions you give the user you connect as, you can have the full power of Salt to do all kinds of things. Our enterprise GUI connects through that same REST API. So everything that happens in the enterprise GUI is the same thing that happens when you're on the command line, and you can see everything that happens on either place. As part of that API, we also have an HTTP stream of the Eventbus. So you can watch for events in a web page and do things based on that stream that's happening. So that's what we're going to do here. Seth House helped me write some of the JavaScript to do this. And then after the event yesterday, he's like, oh, I can make it look prettier. So he, like 10 minutes ago, gave me an updated copy of it. So we're going to try his new version, see if it works, see if it's prettier. If it doesn't, we'll go back to the previous version. Let's see. So this is all it is. Just a little web page. It has some Bootstrap stuff and some jQuery. And we're going to listen on the events stream of our Salt API. And it's going to then listen for events and then display certain events. In the master config, we just need this Cherry Pie server to start up. So we have the Cherry Pie, the ports, and the path that we want to present. Okay, so let's start up the Salt API. You can use the regular init scripts to start up the API, but I'm going to run it in debug mode in case anything happens. I can get an idea of what's going on. All right, so we are up. All right, so here we have my domain. We're on port 8000 and a beacon demo. I have to log into it. Okay. Okay, he changed it a little bit. Okay, so all right. So what's happening here is we are watching this phone number here. And we send a message to that. And oh, geez. And it's not working. All right. What's that? Yeah, well, we have a new document. If it's not going to do it, let me try that again. Okay, so you can see here on the Eventbus, it saw that we had an event come through with the message and information coming from that, but it's not updating our page. So I'm going to revert back to the other one that we had yesterday. And all right, so let's try that one more time. Okay, so the text message came in, and oh, come on. Let me see if I. So we're listening on the master event bus. There we go. Okay. So this is the other version. So we can send anything. So we can actually send a text message or an MMS as well. So I'm going to take a picture here. Say cheese. Send that up. And so again, what's happening here is we have this Twilio account. Our beacon is checking every 4 seconds for texts coming in. When it sees one, it sends an event up on the event master, on the event bus that's flowing through SaltMaster, through the Salt's API, and then we have this web page that's listening on that event bus. There we go. Thank you, whoever sent that. Appreciate it. So feel free, if somebody wants to send something, you're more than welcome to do that. Your text messaging charges apply. Oh, there's mine. Take a moment for it to go through. So, again, this is a very far-fetched example, but it's kind of showing the power of, the incredible flexibility of things you can do with your SaltMaster. So, all right, so I'm gonna turn this off. Because yesterday they kept sending messages, and they never were able to finish the rest of the class. So, any questions on this or comments or?
How is Beacon support on Windows?
I haven't tested it yet, but it should work just fine. Things like the login one. I mean, it's not going to work because it's different subsystems for that. But like there's a log file beacon that will monitor any log file and match on regular expressions. That should work. Things like that. So I have some plans to monitor like the system events, not the logs, but what do you call them on Windows? The regular Windows logs and things like that. Same thing with logging in and out, various things like that. What are the what?
Latency and throughput characteristics.
It's really, really fast. Tom and Mike were testing this the other day, and Mike on his laptop was getting something like, I think it was like 8,000 messages a second, just on his laptop. So commodity hardware, pretty decent laptop, but it's pretty powerful. I imagine it's something you want to monitor if you're running, 30,000 minions spread out, and then they're all sending messages. You may want to see what that does to your master, but we have not had a single person have a problem with the messages overloading their master at this point. So, I'm not saying it couldn't be done. So, all right, let me go back to here. So the question was, are the beacon configurations are push or not synced to the minions? So you can put them in the pillar data for the minion, if you have it with the beacons key, or you can put them directly in the minions config. And anytime you change those, you do need to restart the minion process or service for it to take effect. So here I'm going to disable this for now. And then we're going to enable the WTMP beacon. And there's no configuration necessary for this. And then we're going to modify our reactor for a moment. Who would like to let me use your cell phone as the recipient of my messages? Somebody want to volunteer? What's your number?
What's that?
You want to come tell me your number real quick, or you?
Sure.
I'll see if I can fuzz that out on the video. All right, thanks. All right, so we got that config. Okay, so what's happening here? We started the WTMP beacon, and you can have multiple beacons running at the same time. I just disabled the other one to make sure I didn't interfere with anything. And every time somebody logs in or out of the system, it's going to send an event up to the SaltMaster. If you remember, we had a config here that's going to watch for those events. So here we have this tag we're looking for, Salt Beacon. Again, Boucher is the minion ID, and WTMP is the beacon subsystem. If I wanted to listen for login events on any of my servers, I could put an asterisk here, or you can do any kind of globbing you'd like. Again, you want to keep that very simple, so usually just asterisk would be sufficient for there. And then I just modified the logins.sls file. And here we have this is an arbitrary name I gave it, notify group. We're doing Twilio send SMS is the command. We're going to run that on our Boucher minion. And then we have some arguments we're passing in. So my Twilio count is the count information for that machine. This is the text we're going to send. Inside of the Reactor SLS, you have access to two data structures. Actually, you have access to the Salt commands data structure. Also, we have data that contains the data of the event that came through, and then tag, which has the tag that we did here. So I'm using some of the data that's coming through to output into the audio, into the text. And then we're sending a message to that text, to that phone, and it's coming from this phone number in the account. So let me okay, everything works right. Is your phone on so it should make sound? All right, so if I go to log in. You got text message there. And so it should say the username and the timestamp. There is a little bug. This is brand new. WTP is actually a binary file format on the file system, and apparently between different versions of Linux or Unixes, it changes, and it depends on your, anyway, there's various things. So a lot of times the username will have some extraneous, yeah, it's got some extra characters to it. So if you're on Arch Linux, which is what Tom wrote it on, it'll come out perfectly. But so this is an unreleased version of Salt, so it's not quite there. So the idea here is that the scenario for this situation is you have your production servers that you shouldn't have, your developers should not be logging in and tweaking config files, right? Yeah. You've ever been managing systems and things start acting weird, then you find out a week later that some guy logged in and modified something without telling you or whatever. So this is a way to just send you a text message, just let you know that it happened. Tom was like, oh, we should set it up so if it's, unless you're a certain user, just kick them out, log them out, Other things you could do with the beacons that we've thought about is, like you could monitor your Etsy directory. And if any of the files in there change, I have another demo that I did out in Brussels at Config Management Camp where if you modified any of the files in there, then it would run a high state and push them back to the right state they're supposed to be in. Anyway, there's a whole wide range of possibilities of things you could do with these. Any other questions about these two here. So I'll need to make sure I take one thing off, because yesterday my friend Justin volunteered, and then I forgot to take it off, and then like later on that evening I logged in to do some testing things, and he's like, dude, I keep getting texts from your freaking server, So I'll try to make sure they get that removed here. Thank you for volunteering. Okay, so we're just about done. I just want to give one more example. So sometimes you have, with some customers, we've done some custom things with the Eventbus. And in this scenario, we're building up a bunch of Windows VMs, and there's this whole process that had to happen. Sometimes it involved the same minion that would need to reboot multiple times. Other times, it hit like after the third task, then we would need to do something over on this other server to enable that to attach. And it was kind of a pain doing it. It was kind of difficult to do it all inside one SLS file. So what we did was we created a series of events. So in the reactor, we had 9 tags we were matching on. And so like you can just imagine like step 1, step 2, step 3. And at the end of each one of those steps, the minion would send an event to the master, and then the reactor would do something. So for example, one step, once the minion was configured with a piece of software, it needed to connect into a MySQL server. And that MySQL server had pretty tight IP tables rules, and it was locked down pretty heavily. So to send an event to the Salt Master saying, hey, this new server is ready to go, needs to talk to this MySQL server, then it would redo the IP tables state for that MySQL server, allowing the new server to connect in. And then when that finished, the reactor would see that event had finished. And then the next step was to tell the original server that, okay, now you can connect, start up your services, and things like that. So the reactor is kind of a way to, you can use it to have like a orchestration process that might go through. It also worked for when we had errors. So if we had an error, we could use like the on-fail states modules to send a message somewhere. So with this particular customer, there were a few steps. There's a couple steps where, due to the custom software they were doing, occasionally it would fail, and it required a human to go in and fix something. So, that happened like 1 out of 20 times, and they're just like, I don't know why. It was some other group's problem, and so the 5% of the time that would happen, they would get a notification on their dashboard and an email that this build process had failed at this certain step. So they would go into the VM, they knew where it was supposed to be done, they would fix the problem. Then they could kick off that whole process again, but it wouldn't have to go through the entire process. It could continue right where it left off, and each event would just, as soon as it heard that event, it would just continue on. So they could continue the process wherever it broke off. So that's, again, one other situation where we've used the Eventbus and the reactors. So this is a slide about the monitoring the logins there. Another one's with a Jenkins build orchestration system. So we have some users that will use, have a minion running on their Jenkins server. When the Jenkins server has a build that passes, it will take the SHA or the tag of that build, send that in an event up to the master. And the master has a reactor looking for those successful tests, and then deploy code as needed. And again, it can be an arbitrary complexity, whatever that build process is. So it's a really good way of separating out each of those concerns. The Jenkins doesn't need to necessarily know about your entire deploy process, unless you want it to, because people do use that with Jenkins. The reactor doesn't need to know what causes that event to happen or whatever. So you can have different groups and different people handle each of those sections separately and do the right thing without having to modify the whole infrastructure. So anyway, that's pretty much it. I'll be here. Wait, one more question? Yeah.
Just a quick question. We talked in the first session that was here about the syndic, that I was having trouble syncing the SRV directory from the syndic and then passing on to the minions underneath the syndic master.
Uh-huh.
Would that be a good use case for Reactor when someone does a high state sync the SRV tree?
Sure. So his question was passing when you're using a syndic syndic master below a higher level master. So by default, the syndic is just a pass-through interface. Files in your serve salt directory, pillars, all that type of thing are not synced, by design from your master to your syndics. So yeah, you could use a reactor to, you could send an event saying, hey, we have new data or new files. You need to sync, and they could then download them.
And where someone wants to call the high state command, pick up that event and react to it by pushing those files ahead of time, or that's something.
Yeah, you could probably do something like that, for sure. Yeah, we can talk about that after. Yeah.
I don't see much documentation about how to write your own beacons.
Because they're brand spanking new. So we'll have some docs up soon. So I think there's a little bit of docs on some of it, but even like, I think the first day of the conference, Tom added in the ability to call out to all the salt functions within the beacons and stuff. So it's still very much in flux, but we will get some good docs out for that.
The other question I had was, so this event mechanism depends on minion to be the one pushing the data back to the master. If there is a separate process which is on the same host as the minion, can it in any way use that mechanism to create events without being a root process?
So the question, can the minion send events without being root? You can only send events if you're running as the user that the minion's running as. Yeah. I have set it up. You can actually set up your minion to give that user, the non-root user, sudo access to send just the event. So if you set up a sudo rules correctly in your sudo rules file, you can have it be able to say salt call event.firemaster, and you can specify any arbitrary length of the amount of the command you want to allow it to run as root. So then you can limit what it can do. So anyway. Well, we'll go ahead and end now. We're over time. I'll be here for a few minutes if you have any other questions. But thanks for coming. Appreciate it.